Welcome back to Impact Math with Miss Taylor. Alrighty, we are going to be working on some geometry proofs. I have been a lot of requests for geometry proofs and I'm finally getting to it. So I'm going to be doing mini lessons on triangle proofs. So today's mini lesson is going to be on side, okay? So we have given JK is congruent to KL. M is the midpoint of JL. And the proof. Okay, so I always tell my students, you might not know this middle stuff, but you for sure should know the beginning and the very last statement. Why? Is because it's given to you all right here. Okay, so we're going to start with our first given. Okay, now the given is the reason. These are the statements. Okay, so we're going to put JK is congruent to KL. Okay, and we're going to say given. Then we have, how many givens do you have? How many statements were given? We're given one here and one here. So we're going to write our next one. M is the midpoint of JL. And that's also given. Okay. Now, we have to understand what this means. When it says M is the midpoint, you have to understand, what does the midpoint do? Well, what the midpoint does to a line segment is it breaks it equally because it's the midpoint. So I can know that this side is equal to this side because that's what the definition of a midpoint is. It's the middle. It's the exact middle of the segment. And it creates equal parts because it's the middle. Hope that makes sense. So since this is the middle, so we could say JM is congruent to LM. Okay. And if you have a word here that says midpoint, you could say definition of midpoint. Okay. Now, right now we have two sides. We have a side here and a side here. Now we need our third side. Whenever you have a triangle touch in the middle like this, this is your third side, okay? So we could say that KM is equal or congruent to KM by the reflexive property. Okay, the reflexive property is like the mirror. What you see on the left side should be the same on the right side. And why I say mirror is when you look in the mirror, you're going to see yourself. So this side must always match here. And it's reflexive because both of these triangles share this side. Okay, so you see a word midpoint. They give you this midpoint right here. You're going to say definition of midpoint. So now we have side, side, side. We have our three sides here. Now, where you get your last statement is always the proof statement. So you're going to copy this statement down. Triangle JKM is congruent to triangle LKM. And it's by side, side, side. Side, side, side. Side, side, side. These markings are sides. Alrighty. I will most definitely catch you on the next problem. I have 5 of these. So I hope this helps. Let's go to the next. Okay, number 2. Given. So we're given JK congruent to BC, KL congruent to CD, and LJ congruent. How many givens are you given? Well, you're given 1, 2, 3. So that's pretty much the whole proof that they gave us. So we're going to say JK is congruent to BC. And the reasoning is the given part. Okay, these are the statements. And how many statements you know is by how many commas. So this is the second statement. KL is congruent to CD. And that is given. Remember, this symbol means congruent, which means equal. And then LJ is congruent to DB. And that's also given. So this is side, this is a side, and this is a side. So number 4 has to be side, side, side. My last statement always comes from the proof statement. Never write proof, but it's the statement that you write here from the proof. That's always the last one. JKL, triangle JKL is congruent to triangle BCD, right? We hope our teachers give us one of these. If they could all be like this, it'd be awesome, right? All right, let's go to the next. All right, we have number 3. Okay, now this is called a flow chart, okay? What we were doing earlier is a 2-column chart, 2-column. Now this is called a flow chart, okay? So you're still gonna put your givens. So you see how you have given here, given. So the statements go in the box and the reasoning goes underneath the box, okay? So the first given is RS is congruent to UT, okay? And then we have another given here, which is RT is congruent to US. Remember, you always look at your givens. These are the statements, okay? Now it says ST is congruent to TS. So ST is congruent to TS. So this is called the reflexive property because they both triangles share this one side. So whenever they share a side, always mark that middle. It's a reflexive property. And then this is our last statement. So our last statement is always the proof statement. So we're going to say triangle RST is congruent to triangle UTS. And why? It's because this is side, 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 side. That's our reasoning because we have 3 sides marked. All right. Thank you so much for your support, for liking, sharing, and most definitely hitting that subscribe button. All right, let's continue and I'll catch you on the next one. Given. Okay, so we're always going to start with our givens and you need to know how many givens you're given. Well, I'm given 2 givens here because it's a comma. So I'm given AB is congruent to CB. So let's mark that on our picture. So it told us AB is congruent to BC. So AB is congruent to CB, and that is given. My next given is D is the midpoint of AC. So D is the midpoint of AC, okay? And that is given. So again, you have to understand what midpoint means. So what that is telling us is D is the midpoint of these 2 seconds, of this line segment. So what that creates is 2 congruent segments. This distance has to be the same as this distance. So we could say AD is congruent to CD. Okay. And since I have the word midpoint right here, it's a pattern. I'm going to say directly here, definition of midpoint. Now, number 4. So right now we have a side and we have a side. We need our third side. Remember, our third side comes, so what do they share? Well, they share BD. So this is our third side. So we could say BD is congruent to BD. And since this side is the exact same as this side, we know that's the reflexive property. Okay. Now, our last statement always comes from the proof statement. Okay, never write proof. You always write the statement here. So this is going to be triangle ABD is congruent to triangle CBD by side, side, side. All right, I want you to pause the video. I'm going to go to number 5 and I want you to pause it and try it and see if you get it, if you're catching on to the pattern, if it's making more sense. All right, let's go to the next. All right. So we're going to start with our given. Remember, your given are your statements here. Okay. So you need to count how many givens you're given. 1, 2, 3. Okay. So here we're going to write our first 2 givens. And how I know I'm writing these first 2 givens is because they have them right here. Okay, so we're going to write AC is congruent to AB and AD is congruent to AE, okay? And that's our given. Now, this should have been just an equal to right here, okay? And how I know that this should have been an equal to is because whenever you go from congruent to equal, you're going to say definition of congruence, okay? So you start with congruent, you got to go to equal. Now, you see how you have a first plus sign here? And you see how it says the total AB equals this AE plus EB? That's called segment addition property. Okay? So usually when you have, like, you have to look at the picture, it has a total here, and then it breaks down what you add to get that total. Same thing on this side. See how it says AC, and then it gives you this plus AD plus DC equals the total AC. That's segment addition property. All right. So now we're going to go to substitution. So they told us substitution. So do you see up here where it says AC equals AB? Well, what we can do is we can sub in these two and set them equal to each other for here. So we could say AD plus DC equals AE plus EB. Okay, so we're substituting this part in for AC and this part in for AB. So now we end up with just DC equals EB. But what you have to understand is, see how it has this AD here? Remember, AD is equal to AE. So really, we could substitute in AE here. And then how we can get rid of AEs by subtraction. And so that's why we're going to say this is the subtraction property. Because we're erasing, we're getting rid of this AE. But how we're minusing AE to both sides. And really, we're plugging in AE here for AD because they're equal to each other. So now you see how it says definition of congruence? Whenever it says definition of congruence, you're either going from equal to congruent symbol or congruent to equal. That's the same. So we say DC is congruent to EB. Okay. And then we have another given. Well, we only used our first 2 givens here. So then this is our third given. So we could say BD is congruent to CE. Okay, and that's given. So now we have BD is congruent to CE, and they have BC is congruent to CB. So remember, the left side is equal to the right side. So if you look here, you see how CB and BC work on this triangle and work off of this triangle here. So they share this side. And remember, whenever they share the same side, or it's the same line segment, that's called the reflexive property. Okay, this side is the same as this side. It's talking about one line. And then our last statement here, let me move it on up. Okay, our last statement is always the proof statement. So we're going to put triangle BCD is congruent to triangle CBE. Now, let's see what we actually have here. We have a side, and we have a side. So it's by side, 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 that this triangle is congruent to this triangle. Alrighty, I hope this helps. Have a wonderful, blessed day, and the next mini lesson will be on SAS, side angle side. Alrighty, I'll catch you on the next one. Don't forget to hit that subscribe button and like and share. Alrighty, bye.